So now we're going to start with what's going to lead us into simplifying rational expressions. So we're going to start going back to something that's common and I'm talking about fractions. So when we want to multiply rational expressions, we do it the same way we would do if we were talking about fractions. So with fractions, if I had 3 over 5 and I multiplied that to, say, 5 over 7, all we do is we multiply the tops together and we multiply the bottoms together. The same thing with rational expressions. If big A, big B, big C, big D are all rational expressions, then if I multiply them together, I get these polynomials multiplied together give me A times B, and B times C are polynomials. They're going to multiply together, give me B times D. Sorry, I think I'm going to say A, big B, big C, big D are all polynomials, not rationals. Sorry. Any rational expression with the symbol with the same numerator and denominator is a symbol for 1. So if I have, I think we already know this one, but if I have 73 over 73, that's equivalent to 1. If I had x minus y and x minus y, that's also equivalent to 1. This means that if I find out something like c equals b here, that means I know that this is just going to be equal to 1. So I can always rewrite this as A over D. Here, we'll say this. Okay. So this is going to get us into something that's going to be called canceling. So first we want to multiply to obtain an equivalent expression. So if I have 4x plus 3 divided by x plus 3, and I wanted to have an equivalent rational expression. So we're talking about equivalent expressions. Just so you know, they may not always be equivalent everywhere, which is something that will get brought up a little later. So one of the things I could do is I can just simply multiply the top and the bottom by the same number, because we know that is just equal to 1. So we could just end up with 5 times 4x plus 3 over 5 times x plus 3, which is 20x plus 15 over 5x plus 3. Another thing that we could do is I can take 4x plus 3 and divide it by plus 3. And in this case, I can multiply the top and bottom by, like I said, it just has to be the same polynomial, maybe x minus 1. So I'd have 4x plus 3, and I'd multiply that to x minus 1. And then on the bottom, I just multiply the 2 together. So I have x plus 3 would be multiplied to x minus 1. Like I said, just multiply across the top and across the bottom. And we end up with 4x squared let me do my FOIL the correct way. 4x squared minus 4x plus 3x minus 3 over x squared minus x plus 3x minus 3, which is going to be 4x squared minus x minus 3 over x squared minus 2x minus 3. And what we have here, all three of these are going to be equivalent expressions, or like I said, equivalent-esque. What we're going to see later is that there is a little bit, they're not completely equivalent for every single value of x, but it's enough that usually at this stage in algebra, we just say that they're equivalent expressions. So when simplifying a rational expression, what we're trying to do is find those parts like this. If we went backwards, this x minus 1 is x minus 1. That is something that I can eliminate, and it gets me back to this 4x plus 3 over x plus 3. So this is going to be very similar to when we talk about simplifying with fractions, is that we like to simplify things and get rid of common factors. The rational expression is simplified if its numerator and denominator have no common factors other than 1 or negative 1. I'm sorry, I don't know why that negative 1 is way over there. The following procedure can be used to simplify a rational expression. We're going to divide the numerator and the denominator completely, or sorry, factor it completely. Mixed my two words there. So we're going to put those factoring skills to use again. So we're going to completely factor the top, completely factor the bottom. Then we're going to divide both the numerator and the denominator by any common factors. So in this case, I have 9x squared over 36x. So I know that the top and the bottom both share a 9, and they both share an x. So if I factor those out, on the top I'm just left with x, and on the bottom I'm just going to be left with 4. But we have this 9x and this 9x. So if I take the top and I multiply it by 1 over 9x, and the bottom and I multiply it by 1 over 9x, well, what happens here is I'm basically dividing by 9x, that goes away. And I'm basically dividing by 9x, and that goes away. And this gives me x over 4. But something to notice here, there's kind of a quicker way for me to do this. Instead of doing this whole part here where I'm going to multiply by 1 over 9x, we know that's going to happen, but we can kind of simplify it by just cutting those out. So we can do what we consider here is just this canceling of factors. You just have to be careful about when you do it. So for your worksheet, take a moment and factor these and look for common factors that you have in these that you can't eliminate. And then once we eliminate them, then we are going to be simplified. So we're trying to get rid of common factors. So I'll give you a moment to try this on your own. All right. So once we get to this point, like I said, I just went through and I factored all these. So if I factor 3x minus 12 divided by 5x minus 4, that is just 3 times x minus 4 divided by 5 times x minus 4. So we have this x minus 4 here and here. So once again, I could essentially take the top and just divide it by an x minus 4, and the bottom divide by that x minus 4. So then I'm getting rid of them, and I just have a 0, which leaves me with 3 over 5. So as long as there's this multiplication here, really what I'm doing here is I'm just canceling out a common factor. So as long as the factor is common to the top and the bottom, because this is essentially equals 1, I can make it disappear. Same thing here. This 4a, as long as everything is multiplied here in the top and everything's multiplied in the bottom, these are factors, and we know that this factor just equals 1. So once again, I can make it just disappear. I cancel it out and just say, hey, that's just equal to 1. And then I'm just left with 2a plus 7 over a plus 3. And then my last one, x squared plus 2x minus 15 over x squared minus 9, that factors into x plus 3, x minus 3, or sorry, x plus 5, x minus 3 over x minus 3, x minus 3. Oops, x plus 3. The typo there. But once again, I have this x minus 3 on the top and on the bottom. So we know together this is just going to be 1, so I'm going to cancel it out. Meaning that I'm just left with x plus 5, x plus 3. So like I said, this step that I did here, It's a necessary step. It's essentially what we're doing here to divide away that common factor. But once again, like I said, we can just cancel it out. But these would be the simplified forms. So x squared minus 12 over 5x minus 20 is the same as just 3 over 5, mostly the same. 8a squared plus 28a over 4a squared plus 12a simplifies into 2a plus 7 over a plus 3, and x squared plus 2x minus 15 over x squared minus 9. So simplifies into x plus 3 over x plus 5 over x plus 3. So canceling is a shortcut often used for removing a factor equal to 0 when working with fractions. Like we were saying before, canceling removes factors equal to 1 in products. It cannot be done in sums or when adding expressions together. So it can be only done in cases like this, where we know that these factors are all multiplied together. And you have to have the same factor on the top and the bottom to cancel it out. And a word of caution here is canceling is often performed incorrectly. These are not factored. X plus 7, that is not 2 factors. Well, in this case, we cannot do this cancellation because we need a situation like this. Oops, sorry, something's on my screen stopping me. Where I have everything as factors. These are factors at the top, factors at the bottom. I can get rid of the common factor. When we have this addition, that's not factored. That 5 is not factored out of everything. It's just part of this one term. So I can't get rid of that. This 3 is also not factored out of the bottom. It's just added on. So when we have this case where the number that we're looking at is added onto something, we can't get rid of it. We can only get rid of entire factors. Okay. So one more example. If we want to simplify this, we got x plus 3 on top. And on the bottom, I can factor out a 2. And then I'm going to have 3 minus x. So you might be looking at going, well, I can't do anything else with that. So here's a little trick. So oftentimes when we will see a situation like this where I have x minus 3 on top, but on the bottom I have what is really, it's a additive inverse. I have 3 minus x. So what I could do is in the bottom, let's see, instead of factoring out just 2, I factored out negative 2. So now instead of having 6, if I divide by negative 2, that's a negative 3. Negative 2x, if I factor out that 2, it's just going to leave me with a plus x. If I just rearrange that, because by commutative property, I can just say that this x minus 3 on the bottom. So now we have the same factor on the top and bottom. And really what I'm just left with is just a negative 1/2. So be careful. Sometimes you do have common factors. It's just you have to factor out a negative opposed to just factoring out positive factors. All right. So just one more for your worksheet. Just attempt to factor these ones one more time and doing some cancellations. So pause for a minute and work on this. Okay, so if I completely factor the tops and the bottom, notice here I have an x plus 1 on top. I have an x plus 1 here and x plus 1 here. The only ones I can cancel though, like I said, everything are factors. I can only cancel one of the ones on the top with one of the ones on the bottom. So do not try to cancel like that. It has to be the top and the bottom. Because remember, we're saying that this whole unit here is what's equal to 1. So it's not really a cancellation. It's just saying, recognizing that it's just 1, and then what I'm really left with is just the x minus 1 on top, and then the x plus 1 on bottom. Same thing here. We know this is actually just equivalent to 1. So I'm just left with the x minus 2 on top and the x plus 3 on the bottom.